All right, these notes are just a little few helpful hints on the assignment that we'll be having for part 2 of section 3.3. We talked a little bit about this a couple days ago, but remember how to sketch the graph of a derivative if you're given f. So looking at this line, it's a constant, so it would be like y equals -3, something like that. This graph of the derivative would be the graph of all the slopes. And since all of these slopes are 0, then we're just going to have a line that goes through at y equals 0. So right there, that's the graph of the derivative. And then over here, if this is the graph of g of x, this has a positive slope, maybe a slope of 1.5 or 2 maybe, and it's a constant slope, so everywhere on here would be the same value of the derivative. The derivative would be 2 here, 2 here, 2 here, 2 here. Everywhere on this line, the derivative would be 2. So we'll have a horizontal line at 2. All right. Looking at this graph of the absolute value, what are the slopes of all of these points? They're all the same. They're all about -1. So this graph would have a horizontal line at -1. But then right at 0, there is no derivative at a cusp, so we have an open circle. And then here, these are +1. So we'd have a slope of +1 here. Again, an open circle at 0. This graph, we have positive slopes here, positive slopes here, positive slopes here, getting smaller, and then at 0 here. Here, these are negative slopes, getting bigger, 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 bigger. So I know this is a quadratic, so just knowing that when you take the derivative, the power decreases by 1. So this graph of the derivative would be x to the first of some kind. So positives, 0, and negatives. Positives, 0, and negatives should be a straight line. Something like this, we have very steep negative slopes, so very low values. Here, the derivative is 0, so about here. Here, the derivative is 0, horizontal line, so about here. So really low negative values. Here, these slopes are positive, so I'm going to be positive values for my derivative in between. So it's going to be something like this. Again, we did practice this a couple days ago. If you want more practice, great place to go is this website. That's the website we went to in class. Please practice. What if you're given the graph of the derivative? Make sure that you're able to determine whether f has a relative maximum, minimum, or neither at a critical number. So on the AP test, they'll often give you graphs of derivatives and graphs of original functions, and you need to make sure when you're reading the problem that you're very clear about what they've given you. They've given me the graph of the derivative, and I need to be able to decide whether the original function has certain things going on based on the graph of the derivative. So looking at this derivative, what's going on here and here and here? This is where the derivative equals 0. So what does that mean about the original function if the derivative equals 0 there? That means the original function has critical numbers at, I didn't put markings on this, let's say this is -1, so maybe at x equals -2, let's say this is 1, and let's say this is 3. So you would have markings on the graph that you're given. So we'll say that f has critical numbers at -2, 1, and 3. So let's look at what else is going on. The derivative here, these are all negative values. And the derivative here, because this is the graph of the derivative, these are positive values. So at that critical number, the derivative changed from negative to positive. So at -2, since the derivative changed from negative to positive, that is a minimum. Because if you think about what that means about our original function, the function's decreasing here, and then it went to increasing. So if a function's decreasing and then it goes to increasing, what's happening at -2 is a minimum. So -2 is a minimum. X equals 1. Our derivative is positive here, and then it's still positive because the derivative is above the x-axis. So the derivative doesn't change sign. So x equals 1 is not a max or a min. And then at x equals 3, our derivative changes from positive to negative. So our function goes from increasing to decreasing. So if you like the visual, the function is going like this at 3, and 3 is right here, so 3 is a max. All right, so we've got a max and a min. -2 is our min, 3 is our max, and neither is going on at 1. All right. Talking about different questions that they might ask you on the homework. How do you find a maximum temperature? How do you find a minimum radius? How do you find a minimum surface area? If you want to find the maximum or minimum of anything, you take the derivative of the temperature equation, or the function that they give you. Set that equal to 0. Also find where it's undefined, where the derivative is undefined, and test those critical numbers. So when you set it equal to 0 and find where it's undefined, the critical numbers that you get need to be tested using the first derivative test. And then you can tell if it's a maximum or a minimum. If you're trying to find a minimum radius, you take the derivative of whatever radius equation you have, radius function. Set that equal to 0, etc. You want to find the surface area, you take the derivative of the surface area function, and you set it equal to 0. All right? So whenever you have to find a max or a min of anything, you take the derivative of that thing, and then set it equal to 0 and test it. You'll have a few problems involving motion along a line, and I know that's a physics application, but calculus and physics really go hand in hand. We'll be expanding on this later in the year, but for now we're just going to talk about velocity. Remember, velocity is the first derivative of the position function. Acceleration is the second derivative of the position function. You should already know that. And then the new thing, thinking about how you know if a particle is moving in a positive direction, it's when the derivative, which is the velocity, is positive. And if the particle's moving in a negative direction, it's when the derivative, or the velocity, is negative. The particle changes direction when the velocity changes sign. It's just like speed, going to the right or the left. Velocity is speed with direction. So if it's a positive number, if your derivative or your velocity is positive, it's going in a positive direction. If your derivative, which is velocity, is negative, you're going in a negative direction. All right. And your homework, page 187, 57 to 81 odd, 89 to 93 odd, and 99 to 101 odd. I guess I could have just said 99 and 100. All right, have a great night.